We want to find the volume of the solid formed by rotating the region bounded by y equals e to the power of 3x plus 2, x equals 0, x equals 0.8, and y equals 0 about the x-axis. Looking at this graph here, here's the function y equals e to the power of 3x plus 2. The y-axis is x equals 0. This vertical line is x equals 0.8, and the x-axis is y equals 0. So we're rotating this bounded region here about the x-axis, which forms this solid here. So our goal is to find the volume of this solid. To do this, we'll be using the disk method, where the volume is equal to pi times the integral of f of x squared integrated with respect to x from a to b. To understand where this formula comes from, it's helpful to sketch a rectangle that would be a slice of this region here. Notice how the width of this rectangle would be delta x. This is the reason why we're integrating with respect to x, and the height of the rectangle would be the function value f of x. If we rotate this about the x-axis, notice how it would be a very thin right circular cylinder, which we'll call a disk. And it would look something like this, where we know the volume of a right circular cylinder is equal to pi r squared h, where this would be r, and this would be h. And we can see the same formula in our integral. Here's pi. Instead of r squared, we have the function value squared. And then instead of the height, this would be dx or delta x. So what this integral is doing is finding the volume by finding the sum of thin slices of the volume, which are right circular cylinders or disks, and as a number of disks or right circular cylinders approach infinity, the volume would be equal to this depth integral. So let's go ahead and set this up. We're going to have the volume is equal to pi times the integral of f of x squared, which is going to be the quantity e to the power of 3x plus 2 squared, integrated with respect to x from 0 to 0.8. So what we'll do now is find the value of this depth integral using technology, and then I'll show how to work this out by hand. So we'll first enter pi, and then times this depth integral. So we'll press math, arrow down to option 9, which is function integration. Press enter, and now we'll enter the integrand, which is e to the power of 3x plus 2 squared. So in parentheses, e to the power of 3x plus 2, all of this squared, comma x, the variable of integration, comma 0, the lower limit, comma 0.8, the upper limit, and enter. So this volume is approximately 115.137 cubic units. But now let's show how to do this by hand. The first step would be to square the quantity e to the power of 3x plus 2. There's no shortcuts here. We'd have e to the power of 3x plus 2 times e to the power of 3x plus 2. And we'll have four products, 1, 2, 3, and 4. So we'll have e to the 3x times e to the 3x. We'll add the exponents because we're multiplying. That would be e to the 6x. And then we'll have plus 2 e to the 3x plus another 2 e to the 3x. That's plus 4 e to the 3x, and then plus 4. So let's go ahead and rewrite this. Next, we'll find the antiderivative of each term. To integrate e to the power of 6x, we'd have to perform u substitution, where u is equal to 6x, differential u is equal to 6 dx. So if we solve this for dx, we divide both sides by 6. So we have 1/6 du equals dx. So we can think of this as e to the u, but when integrating, we'll have an extra factor of 1/6. So the antiderivative of e to the power of 6x would be 1/6 e to the power of 6x. We'd have to perform another substitution for 4 e to the 3x, where now u would be equal to 3x. So du is equal to 3 dx dividing both sides by 3, we'd have 1/3 du equals dx. So we can think of this as 4 e to the u, but we'll have an extra factor of 1/3 when integrating. So we'd have 4 times 1/3 e to the 3x for the antiderivative, or plus 4/3 e to the 3x. And then the antiderivative of 4 would be 4x. Now we'll substitute x equals 0.8, then x equals 0, and then find the difference. So when x is 0.8, we'd have 1/6 times e to the 6 times 0.8 plus 4/3 times e to the power of 3 times 0.8 plus 4 times 0.8. And then when x is 0, we'd have 1/6. This would be just e to the 0, which is 1, plus 4/3. This would be e to the 0, or 1. And this would be 4 times 0, or just 0. Now let's go and evaluate this on the calculator. So we'll have pi, and then we'll have 2 open parentheses. Then we have 1/6 times e raised to the power of 6 times 0.8 plus 4/3 times e raised to the power of 3 times 0.8 plus 4 times 0.8, close parenthesis, minus the quantity. Since e to the 0 is equal to 1, this would just be 1/6 plus 4/3. Close parenthesis, and another close parenthesis, and enter. Notice how we have the same value. The volume is approximately 115.137 cubic units. I hope you found this helpful.